favorite things that I remember when I was learning chemistry forever ago. Am I presenting the right slide? Yes, I am. All right, so in Canvas, and let me double check and make sure I didn't mess any of that up for you guys. Yes, there is an opener. Okay, so, and we just did this. So what do ionic compounds always start with? What's the first thing that is always going to be listed element-wise? The metal, right? So if the first thing you see is a metal, then it's going to be an ionic compound. So what do covalent compounds start with then? Because it's not a metal. It's not metals. Of course, let me get rid of that so it makes it just a little bit larger. So yeah, all you really have to do is to look at the first thing to see if we're going to have an ionic compound where they steal electrons, the nonmetals steal the electrons from the metals, or if we're going to have a covalent compound which they share them. Then we had that PhET lab that you guys were taking a look at on Friday, which actually let you do three-dimensional motion on it, which is sort of cool because we didn't have that. When I was your age, we had these, they look like, not Legos, but like keeper toy kind of things where you'd have bonds, whether they be double, single, triple, and you'd have lone pairs of electrons, and then the different balls that you'd stick on the end of the sticks would be different elements. So we had something similar to it. It was just all like model stuff. It wasn't virtual. Okay, I have it printed out. How many of you want the paper version of this? This is going to be very difficult for you guys to do hardly anything, especially since Candy is still down, right? Down this morning. Yeah, I think it's still down. So, let's paper. No, Candy, the app that you use to draw and stuff, this morning, whatever engine runs it is down, and I don't know if it's back up or not. You want to put the version here and try to get it online. Because I don't know if it's still working. And so if you're remote, I don't know what to tell you. Unless it's a GMT paper version, yes. You can try, but doing all these dots and stuff is going to be difficult if it's not functioning right.
It's not available.
It's not available?
It says last updated 2 years ago.
For Cami?
And it says Cami unavailable.
Yeah, they're working on it. That's all I can tell you. So I'm so sorry for those of you that are online. That's something that is out of my control. I can't, sorry. But molecular compounds, if it's necessary, they're going to share electrons with each other. And they can do so in one of three ways. They can do single, double, or triple bonds. Each bond represents 2 electrons that are actually counting for both elements. It's cold as hell. It's hot.
It feels good.
It's, well, I mean, I don't know. This room has such a really sensitive region, right around 70 degrees, where it's like, you tell it to 1 degree and either way, it does like 10. Okay, so you have at least 2 different elements, and they will be sharing electrons in bonds instead of stealing them from each other like on ions. And so we show a shared electron as a dash, okay? If they're a lone pair of electrons, then it's 2 dots. And I can't remember how I put this on your paper because I changed. A lot of this stuff is done in PDF format for the other teachers that are here, and PDF and I do not get along very well. I don't think the right software is loaded on this computer. Let's see how I do it for you guys. All right, so a single bond are sharing 2 electrons. Remember, E with a minus is how I abbreviate electron. So either with ionics, we showed it like this. Really, what we do, and you can't see me pointing at the board online, what we really do is we use a dash to represent your electrons if it's between 2 atoms. Now, if they're a lone pair, then we tend to use 2 different dots like this. And I'm going to show you a bunch of different examples that we're going to go through and do this with. It's really horrible that today is the day that whatever the software is that runs Cami is just not functioning. So it's, well, and I can't get the bandwidth and stuff. It's obviously not my fault. I mean, I was in the middle of getting all my stuff done yesterday, throwing it into Canvas, and then I had a power surge, and so I lost a bunch of stuff because my router went out for my internet. I said some not so nice words.
That's all weekend, and all week, yesterday.
Yeah, that is something that is totally out of our control. Okay, so you'll see how these dots, I didn't animate the dots in properly, but you'll see how they go around this in just a second. A double bond is two bonds. Each bond has two electrons, so they're sharing a total of 4. Each line represents 2. So I have never seen somebody put them side by side like this before. What we do is we do 2 dashes. Or what I used online is I used the colon here, and I used an equal sign for this if you're having issues trying to do stuff with this document. That's how I got around it. That's what I did. Now, once again, I have never, ever, ever seen a chemistry teacher do a covalent or a molecular bond like this. You do them like this. Each shared bond is a line. You have here, this is going to be 2 different oxygens. This is a molecule of oxygen gas. Each oxygen has 6. 2, 4, and then if I say these 2 are that oxygen 6, and then this oxygen 2, 4, 6, but when these 2 are shared equally between them, each oxygen now has 2, 4, 6, 8, 2, 4, 6, 8. Because those electrons in the middle, they count for both of them. They're shared equally. And we know that the octet rule doesn't necessarily mean 8, but almost every single element, it is 8 around the outside shell. But they are counting for both of them. This represents a total of 4 electrons, not 2. Okay, so there should be 2 sets of electrons on each oxygen atom, 4 lone pairs, right? So 1, 2, 3, 4 total lone pairs. Then there are the 2 sets in between that are being shared. You guys have that on the paper? Triple bond. We have 6 electrons that are shared. A triple bond is going to be, oh, how did I really not put it? What happened to my extra line? Oh, what happened to my extra line? I had an extra line. Let me fix it. I seriously had an extra line. I need to underline you. I need to underline you. I don't know how they vanished. They were there when I was checking all this. Oh, well. Okay, so that's supposed to be 3 lines. You guys know I can't draw on my board. I try to draw on my board and it goes psychotic. In fact, I don't even know where my ink is. There it is. Go over there. Go away. Uh-oh, I may have lost it. Oh, it's there now. And now I don't know where it is. There it is. You guys know full well I can't draw on my board if I try to. I don't trust that this smart ink over here on the side is actually going to go where I want it to go and move it over there. I really don't know how I lost my triple bond. Oh well, it's no big deal. So each nitrogen has 5. So 1, 2, 3, 4, and let's just say that this one up here is to the right, 5. And then the other 5, so this one, these 2, and these 2, that adds up to 5. But if they're sharing 3 of their individual electrons with each other, that means it counts for both. And so, yes, I know this is supposed to be up in the top, but I seriously do not want to try to draw on my board. We have 2, 4, 6, 8, and we have 2, 4, 6, 8. Each nitrogen has 8 electrons. There you have a full octet. That's what a triple bond looks like. Actually, drawing a covalent Lewis dot structure. Wait, okay. You guys have this. Make this a lot easier and faster. You add up all the valence electrons for each element. The group number. Not the atomic number, the group number. Each element. If there's 2 of them, then you need 2 times their valence electrons. And then you're going to divide by 2 to figure out how many electron pairs you have. This should all be already filled out on your notes page to make this go a lot faster. You arrange your atoms if there's an element that's by itself or if it's carbon, it almost always goes in the center. Then the duplicate atoms or the non-carbon things, depending on what we're building, go around it. You're going to draw a single bond, one line, between the central atom and any atom that goes around it. Each line represents one pair or two electrons. And you're going to subtract that from the total. I'm going to show you how to do this in a second. Yes, this is complicated, and with Candy not working, I'm so sorry, my remote students. You're going to put electron pairs, they go in pairs, two dots, around the outside atoms until they're full. Then you're going to subtract those electron pairs from your total. If you need to double check to make sure that your central atom is full, it means it has 80 electrons. If not, you're going to move lone pairs towards the center to create double or triple bonds. This is a lot of stuff that we're going to be doing at once. If your central atom is full and all of your other electrons are being used and you're down to zero, you're done. If not, you need to move your outside electrons, your lone pairs of electrons, onto the central atom to share them so that you do have a full octet. This was, seriously, y'all, this was the hardest thing I remember doing in chemistry. All the other stuff, I was like, oh, it's just math. This technically is math, but you have to follow the steps. Don't worry, we're going to work through a lot of them together. Okay, so this is, you have this. I'm so sorry, it's so funny, but you have this on the thing. We're going to do carbon, no, it's nitrogen chloride, trichloride for that matter. Nitrogen is in group 5, it has 5 valence electrons. There's one of them. That's 5. There are 3 chlorines, it's in group 7, there's 7 each. So 7 times 3 plus 5 is a total of 26. Divide that by 2, and I have 13 pairs. All I did, especially for those of you that have a hard time reading the small stuff, I took where it's doing it on the left, and I just blew it up on the right. I have 13 pairs of electrons. You've got nitrogen would go in the center because it's the single atom. The 3 chlorines are going to go around it. I'm going to do 3 chlorines. You're going to put one line in between each from the center to its outside atom. So each of these represents 2. So I have a total of 1, 2, 3 pairs of electrons that have been used. Started with 13 pairs. 13 minus 3 is I still need 10 more pairs. So what I'm going to do now is I'm going to put 1 here, 1 here, 1 here. That's 3, 4, 5, 6, 7, 8, 9, 10. Now, you have 1 pair left. 1, 2, 3, 4, 5, 6, 7, 8, 9. Right, so 10 minus 9, I have 1 pair that's remaining. And it's going to go here because my nitrogen does not have 8, it has 6. But if I put a lone pair above nitrogen, then now everybody's full. So each element, find its group number, figure out how many total electrons you have, divide it by 2, that's your pairs. You're going to start by connecting a line, one single bond. You may have to come back and change it to double bonds. Maybe they cannot see me pointing, but you're going to do 1 for each around your central atom, which is carbon, or if there's no carbon, it's a thing by itself. Then you're going to come back and you're going to subtract that from the total. So 13 minus 3 was 10 more. Then you're going to do lone pairs around all of your exterior atoms. So 1, 2, 3, 4, 5, 6, 7, 8, 9. You subtracted that from the total, which was 1 pair left. Well, that one missing lone pair makes nitrogen have 8. This is more complicated than what you guys are used to. And on top of it, they need you to figure out what shape this is. The computer program told you yesterday, or Friday, if I say yesterday, I mean Friday. Carbon dioxide. This is where it's going to be really difficult for those of you that don't have Candy to get this done on the thing. We're going to count up the, even though I put the total number of electrons up there. Carbon has 4, each oxygen has 6. You add those together, and that's 16 total electrons. Divide that by 2, I need 8 pairs. So that's how I got these 2 things. Carbon has 4, 2 times 6 is 12, 12 plus 4 is 16 electrons, divided by 2 is 8 pairs. So I'm starting with 8 pairs. Connect one of each. Connect one between the carbon and the oxygen. I don't know if that's email or if that's my remote students here. Hold on here. Oh, I see slate now though. I have another student that has to quarantine.
Imagine.
No. Oh, it's people are not taking this seriously. It's not in this class. No. Not taking it seriously anymore, and it's all right. Anyways, we had a total. Now you can do this. You can either do this by total electrons or you can do this by pairs. I had 16 total electrons, or I had 8 pairs. These represent a total of 4 electrons. I have 12 left, or 8 minus 2 was 6 pairs. So I still need to deal with these 12 electrons with 6 pairs. And I'm going to start putting dots around it, which is awesome. But how many electrons are around carbon the way that I did this?
0.
No. You gotta count these for both. Both oxygens have 8. They're like, woo! But how many? Carbon only has 4, and it's like, So what we're going to do is we're going to move a lone pair up here, and we're going to move this lone pair up here, and we're going to create what is called a double bond. And I should have done this. I sure did. I did this on the right thing. So carbon has a problem. I don't know why I'm hearing people eating in here. I should not hear crunching in anything. You are aspirating and stuff from inside your lungs every time you take a bite of something. So this is what it ends up looking like. You hold, and if I would have, I'm so sorry if I have anybody that's colorblind in here. It's red. I'm sorry. I didn't even think about that. But I've sort of pulled one of these up here, and I pulled another one over here, and then what happens is these electrons sort of spread out around the other side of that oxygen. Lights repel. They move in pairs. But negative, 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 they want to move as far apart from each other in a pair as they can. They spread out. And then the only thing that's really left is we need to figure out what shape this is. That geometry pattern that the computer program was just telling you. Was it trigonal planar? Was it linear? Was it bent? In this case, this is a linear molecule. Perfectly happy in a straight line. Carbon monoxide is also a linear molecule, but it has a triple bond. That's not on this one. All right, that's for shapes. I hated this stuff too when I was your age. We're going to create water, and then we're going to figure out which of these water is going to be. That program did it for you. So H2O, 2 times 1 is 2, plus 6 is a total of 8 valence electrons, which is 4 pairs. So oxygen is the lone element. It goes in the middle, and then the hydrogens go on either side. Now, I know full well this isn't going to be linear, but we got to figure that out over on the side once we know how many atoms are stuck, because I do have 2 atoms stuck to it, which could be linear, but I need to figure out how many electron regions I have. So first start by connecting the central to however many things are around it, which is 4 valence electrons. So I have 4 valence electrons that are remaining, or 2 pairs. I'd rather do it by pairs. It's the same thing. It's just valence electrons are the whole number, and the pairs, you cut it in half. So you cannot put extra electrons around hydrogen because it only holds 2. So they have to go around oxygen. That's probably the trickiest thing about this. Hydrogen can't have more than 2. It already has 2. It's sharing 2 over here, and it's sharing 2 over here. Now, I have a total of 1, 2, and then the lone pairs count as a third type of electron. So, I'm sorry, third and a fourth type of electron region. I have a total of 4 regions. I have 2 atoms that are attached to the hydrogen, so that is this bent configuration, which I can't remember. I put it over here on the side. This is actually what it ends up looking like. This is why I said it was gonna be so much easier to draw this out today. That program's good for you. So electron regions, there's 1, 2, 3, 4. There are 2 atoms that are stuck to the central, 2 atoms stuck to the central, 4 electron regions is a bent configuration, which looks like this. I do not know how much of this is on the test, because Colin made it, and then I uploaded it into my module, and then somebody that's remote in this class tried to take it. We haven't even covered all of this stuff. So I had to, since somebody's tried to take it, I can't unpublish it, so I've had to throw an access code on it, because I haven't even gone and allocated the points. So a person messed all different kinds of stuff up. I don't know if I can delete it out and recreate it. I may try to do that and then just delete that person's submission, because I haven't altered that test yet. I know I told it to unpublish everything except for today. I don't know what happened. All right, so you guys can already see all of my math. I didn't animate this part. I have 1 carbon, which is 4. I have 4 chlorines, each one is 7. So 4 plus 7 times 4 is 32. You don't believe me? Go ahead and check me, I'm not wrong. But that divided by 2 is 16. So whether you do this as a total electron count or you do it as a pair, I really don't care. I'd love to be able to draw on my board next to it, but I'm not even going to try. So 4 chlorines. You're going to go ahead and do 1 bond for each. Okay, so this is a total of 2, 4, 6, 8 electrons. So I subtract that from my total. I need 24 more. Carbon right now has 8, so it's all kinds of happy. It's fine. But the chlorines only have 2. So I'm going to start putting in pairs. I'm going to start putting electrons around it. And I've got 24 of them to do this with. So I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 times 2 is 24 electrons. You have to do anything else. If I've already gotten down to 0, is carbon of 8? You're fun, you know, I don't know how to do this. I'm going to show you the people that are doing this. Everybody has a full octet. This particular shape is called tetrahedral. If there's all 4, there's no lone pairs anywhere. Everything sticks off. Up, down, left, right, like a cross in tetrahedral formation. We've got to do the ion. Okay, there is one on the assignment that is an ion that's a little bit more difficult. We're actually really good on time where I can try to help you. I need to go over, people are missing turning in things. Some of you turned in a paper version, excuse me, because the due date had not happened yet. I don't think. I don't like to write things until I have everybody turned in. This Lewis dot, this one, a lot of you already turned it in. I just didn't. Well, a lot of you, Jimmy, Veronica, and Tiffany, I'll have your paper version. All right, one more. The chlorate ion is what this is. It has 1 chlorine, which has 7 electrons. It has 3 oxygens, each has 6, but it has a -1 charge, so I have to add 1 to that total, which gives me 26. So whether you do this starting with 26 and just subtracting at face value, or you do it starting as 13 and subtract pairs, I don't care. It does the same thing. Chlorine goes in the middle, and I have 3 oxygens. Each one gets a bond, so that's a total of 6. 3 pairs. So starting with 26, this 6 minus 6 valence electrons comes from the bonds. 2, 4, 6. 2, 4, 6. Then I'm going to come back and I have 18 that I'm going to start putting around the oxygens. So I've got 1, 2, 3. So that's 2, 4, 6, 8, 10, 12, 14, 16, 18. Subtract that from my 20. And I have 2 left. Guess where those 2 electrons are gonna go to make chlorine happy? Up here. You have to have your central atom have 8. And really the only weird part is if it's a hydrogen that's sticking off, it can only hold 2. Almost everything else that you're dealing with is going to have an octet of 8, not an octet of 2. So this has 3 bonds. It has a 4th electron. And this ends up being what's called trigonal. Gosh darn it, little black line, go away. Go away, little black line. There it goes. Trigonal pyramidal, which has a very, very, very specific shape. I'm not going to make you draw 3-dimensional stuff. Like I said, I have to go back into the test, and I need to alter the amount of points. I'm probably going to have to totally delete that test, create a whole new one, restart everything. Because I don't know why that student decided it was okay to like take a test. Should have noticed. Well, you only get 1 attempt. You probably opened it and then went, oh crap, but it's timed. I don't know. I have to figure out what happened. Let me stop this.